The first part will be, I'll talk a little about, well, it'll be in three parts. First, I'll talk about Kivy, show a little what it can do. Then we will build a desktop application, which is the most of the tutorial part. Then we'll take a break after that. When we come back from the break, we will turn that application into an Android app and talk about all the things involved with that. So, here we go. So this is a quick, I should have had this up earlier, but oh well. In case you're in the wrong place, this is what we'll be doing. So who am I? By day, I'm the whole IT department for a small company in Grand Rapids. At night, I work with a lot of user groups. And Kivy is sort of something else I do on the side. So I'm a little interested in who you are, especially since there are so many of you, which is awesome. What do you guys develop on? Is it mostly Windows? How many Windows developers? On Windows, I should say. OS. How many are using OS 10? Okay, and Linux? Pretty good split there. Awesome. And then, how many of you deploy to Android? Make Android apps, or want to make Android apps? Oh, look at all the arm hands go for them. How many want to make iOS apps with this stuff? All right, pretty good. Thanks. That's very insightful. So, what is Kivy? The official description of it is an open source Python library that uses OpenGL for rapid development of applications that make use of innovative user interfaces, such as multi-touch apps. But what is it to me? I think of it, to me it's Python, which is very important. It's a GUI and application framework. It works on all my favorite platforms, which are Linux and Android. It also works on other platforms, which a lot of you are interested in. It can make Android apps in Python, which is very cool. And you can run those apps on the desktop, so you don't really need to run them in the Android emulator, which can be very slow if you've ever tried it. And they can even be modified right on the Android device after you got them on there. I think that's really cool. And it's run by a mature and interesting and stable team of people, which is a big plus on something like this. So what does Kivy run on? It runs on Windows XP 7, and I know someone's working on 8. I don't know if it works on 8 yet. All I hear is grumbling from people trying it on 8, so I don't know. It runs on OS 10. Yep. And Linux, they have many distros now. OpenSUSE, Ubuntu is the main one. Arch. Someone was even trying to run it on FreeBSD, I think. I'm not sure how far they got, but. And you can also run it on Android and iOS. So, I should add in there also Raspberry Pi is most of the way there. I guess the touch screen part is not quite working yet, but you can use a mouse with the Raspberry Pi on it. So that's cool too. So I'm going to show you first a few Kivy apps to give you an idea of what it can do in case you don't know. Where did I put that? That is out. I'm in the wrong place. Sorry about this. Where are we? We are at Pi, Ohio in 2013. Here's a short video of a pretty cool touch screen that was written in Kivy. We can jump ahead to about 20 seconds here. There we go. Yeah. So you can see a lot of the widgets here. There's buttons. It's hard to see it on this screen, but these are also buttons. There's some sliders in there. He's got different layout panels. It looks like a grid over there, maybe a box over here. You can see all kinds of cool interaction. This is an app for controlling a soundboard or a music board or something. I just like it because it has a lot of widgets on it. You don't usually see that many widgets in an app. And then he goes and he had a pop-up with some more buttons in a box. So that's pretty cool. We'll get out of that one and go back to this. There's the demo site. I'm not going to take you out there now because you can go out there by yourself if you want to. The Kivy Touch Tracer app is pretty cool. I'll skip that just for time and show it on Android. The same with Showcase, Flat Jewels. So let's just fire up the Android one. The rest of these are actually Android apps. So I'm going to switch real quick and project over here off of my tablet. So could you hit the lights right behind you? Just hit off and it'll slowly get darker. Let's see if we can get this to come up. There we go. Don't know how easy it is to see, but we'll give it a go. So here's the touch tracer. It's up. You can see multi-touch. I'm using 3 fingers. Each line is a finger. And these are just tracing my fingers. There's 4 fingers. So that sort of shows the multi-touch capabilities. Another one is this picture demo, where I can move these pictures around just with my finger, and then you can zoom in by, doing the whole spreading and squishing of your fingers, and you can turn them, that sort of thing, that sort of interaction. And the Kivy Showcase shows a lot of the widgets, which we saw some of them. Here they are. You got your buttons. That is hard to see, isn't it? Sliders. Text boxes over here. Different text boxes, including a password box. Progress bar down near the bottom. Then there are complex widgets, like this accordion view, where you touch one and it opens up. We've got different panels that you can put in there. There's on the right, there's a file chooser, which is a sort of a tree view. Oh boy, what did I open? So you can do that stuff, and down below it is another type of file opener. More complex widgets. This is a color selector with sliders, so you can also adjust it. Maybe. What did I do wrong there? That one's being a little funky. There we go. So you have a color selector. One type of layout is called a scatter, where it just puts things all over the place. And I thought you could move them here. We can just move some of these things around just by touching and dragging. Some more tree views. You got various font sizes that you want to use. There's pop-ups. This is a little pop-up window. A lot of different layouts. Come on. Oh, there we go. So there's a few different layouts. This one's the anchor layout, which just puts it right after each other. And then the box layout stacks things horizontal or vertically. So there's a horizontal, and it switches to a vertical. There we go. And then float layout, you can put things basically wherever you want. Grid layout. Obviously it's a grid, that's pretty easy to understand. And a stack layout is kind of interesting. It just puts them after each other in the best way it can. And then a relative layout helps you when you get into some real complex situations for placing things. So that's the Kivy Showcase. It's a way to just see some of the widgets. Here's a little app that one of the core creators did. This is like one of his tests. He just uses this to test sound input and output. So it's reading the microphone from the Android tablet here and just displaying it on the screen in a sort of cool way. We'll do Flat Jewels. This is a short game made by that same core developer, Tito. I forgot to start this one up. Or maybe it's going already. Hello. Oh, cool. That one has sound. Let me turn that down. That has too much sound. Oh, so it's a jewel-like game where you move these little things around. And you get points, all that good stuff. Oh, wow, that was too loud up here. Particle Panda is a cool one to show off. It creates particle effects that you can use in games and also in other Kivy apps. So that little blob on the left is particles being generated. And it's got all these sliders and settings on the right that you can change. Some of the easiest ones to see on this screen are things like color. So now they're starting to go to pink, and you can change this. And then you can change the size of these things. So you can make them bigger so they end bigger than they were. It's just a really cool thing to play with. And I believe they open source this app, the particle Panda people. And I think that's all we'll do right now. Let's turn this thing off. Shut that. And we'll get back to the presentation. So that gives you some idea of what you can do with Kivy. You can do a lot of like traditional layout stuff, and you can also do some cool animations and effects using OpenGL. I haven't done any of that stuff yet, so if you ask me a question about OpenGL, I'm just going to, I have no idea. Sorry. Installation of Kivy. Just here for the tutorial. Thanks for the... we have a virtual machine. I create a virtual machine with VirtualBox, and then inside that I've already installed Kivy into that. And that's not really too bad to install, but the Python for Android stuff, there's a lot of work to install that stuff. So if you're sticking around for the second part, you probably will want that virtual machine. There are also Windows and OS X installers for it on the drives in front of you, and available on the website at kivy.org. #download. So now, all right, enough talk. Let's make our desktop app. So I'm going to switch here to the virtual machine and go in there. What do we got? So what I have is, can you guys read that? Probably not. Let's change that color. How about we go more like white with black? Is that better? Oh yeah, that's much better. And then let's see, how do we make that font bigger? Here we go. Zoom up here to 16. How's that? Can everyone read that? Okay, excellent. So what we've got is the tutorial is in steps. Basically, we're going to go through each of these steps and just change a few things between each step, and I'll explain what's happening. And we'll build up an application from basically nothing to this one here. So this is the application we're going to make by the end. You can see basically all it does. Let me turn up my sound, see if we can hear it. It just speaks whatever is typed in the box, so you can type in here. Ooh, that's a little weird. Does that show up on there? Funky effects. That doesn't usually happen. Wow. What is going on now? This always happens, doesn't it? All right, it doesn't want to run in the virtual machine over the VGA. So we will do see if it works out here. Won't work out there. Anyways, that's the app we're going to make. Hopefully it'll work. It did work earlier. I think it has something to do with going over the VGA cable here. It's messing it up. What do we have off the bottom? That's weird too, it runs off the bottom. We'll just clear it. Alright, we'll try it one more time just for fun.
Hello, Will.
I don't know if you could hear it, but it spoke it. It seems to be having trouble. Maybe when I get in there. Here we go. Now we're talking.
Hello, Will. Hello, Ohio.
Ohio, yeah. That's fine with me. So that's the app we're going to make. Oh, I forgot to show the other part of it. This is just a slider to grow the font dynamically. That's a cool thing I added in like 5 minutes. Didn't take me very long to do that. Okay, let's clear this again. And we'll start with step one. What do we have in here? We've got 2 files to start with. You can technically start with just a main.py and do your GUI stuff in there programmatically, but it's highly recommended you learn the Kivy language for the GUI. And so that's what we're going to start with here. So what do we have? In main.py, oh, that goes off the bottom, doesn't it? There we go. We have, those letters are cut off, but you can probably guess what they are. We start with the import statement. We import Kivy, and we say what version it requires. 1.71 is the current stable version of Kivy. We import the app object, and we'll start with a basic layout, which is a box layout. So down at the bottom is where we run it when we go in. We create the class, the app class, and all that really does is build and return the class of the box layout. Now you see that doesn't really do anything yet, and it looks like it doesn't really show anything, but that's because the GUI portion is in the Kv file. So these are the contents of the Kv file. It's just the Kivy version, and in brackets the name of the class from the other part. So to say this class with the box layout. Those get hooked up automatically when you start, and they become one class. So this class and the Kv file get combined magically. A lot of people don't like that magic, but it works. So let's run this. And as you expect, we get a nice empty window. Isn't it beautiful? And so let's go to the next step. All right. We still just have two files, and in fact, for many of the next few steps, we're only going to work in the the Kv file. We're just going to build up that GUI first, and then we'll add the actions onto the buttons and such. So I'm just going to show that. Let's clear. Yeah, got to hit enter. All right, so what we have, we've added a bit to this. This orientation, if you remember, we're using a box layout, so that we're going to say vertical because the layout was vertical in there. We're going to add the label at the top, which will be the heading. Just says say this in it. The text input, the main section. A slider, which is that font sizer. And at the bottom we're going to have a horizontal box layout for the two buttons. So to put them side by side. And we add the say it button and the clear button. So it's pretty simple. Let's see what we have. So when we run this with the default layout settings, you'll see each section. So we had the label, the text, the slider, and the box button at the bottom. They're each allocated an equal amount of the screen. So 25%, 25%, 25%, 25%. And that's the default behavior. If you don't want that, then you go in and tweak it. And you almost never want just the default behavior, right? Because it's kind of weird looking. So as we go along, what we're going to do is we're going to modify this to look like the end result should look. So let's go on to step 3, size hinting. And we're still just working in the Kv file. I can't get all that on the screen, so I'm going to do, where did that go? I'm going to shrink this font just a little so I can get it on there. Unless there's some other way to say stay on the screen. I don't see it. So we'll go down to 15. There we go. Now it all fits on. Okay. So what I've added here, we're still in the Kv file, is the size hinting. By default, the size hint is 1, 1, or 100%, 100%. That means 100% of the width that you're allocated and 100% of the height that you're allocated. So since these are all on the same level, because they're at the same level of indentation in the Kv file, the box layout, slider, text input, and label, by default they were all size hint 1, 1. They had 25% each, an equal share. Now what we're going to do is turn off the height. So the width is still 1. I still want them to take up all of the width that they're allocated, but I want to do more with the height. I want to make that look a little prettier. And at the bottom we do that too. Even in those buttons on the bottom you have to turn that height off, because otherwise they'll use their default height. So this size hinting really trips up a lot of people new to Kivy. It's very important to understand how it works. It's really pretty simple once you get it, but if you're just like diving in and your widgets are like all over the place, weird sizes, you can't figure out how to size them, it's because your size hinting is wrong. You haven't turned it off. And it's using 100% plus whatever you're trying to do to it, and it's getting crazy. So let's see what we have with this. So now I've turned off the size hinting, the height, and you can see this, the top one shrunk up quite a bit. The text box grew a lot. It expanded to take up the space that it's allocated, and these shrunk up to default height. Now the default height is 100 pixels. So actually the top, the slider, and the button boxes are all 100 pixels tall. And the default height for the text will just expand. So let's go on to step 4. Nope, gotta go back. And we'll mess with the heights a little more. Okay, so we're going to adjust those heights a little bit more so they're not just 100 pixels on those elements. So what you do to make it pretty, you could just type a height in there, right? You could say, oh, I want this 50 pixels. That's fine. You can do that. You start to run into trouble when you go to different screen resolutions, though, right? 100 pixels on your laptop is different than 100 pixels on your phone. So what we try to do is there's a resolution, or there's a type of unit that Kivy has that works better at resolutions. It's called an SP. And so we'll deal with those. I don't actually see any yet, so we'll talk about them later. But what I'm doing here is I'm going to shrink those as much as I can. So I want to collapse that height from 100 down to the minimum to display in the label just the font. So the minimum height that you can still see those letters. In the slider, you can't quite do that. You have to do a static size. But in the buttons, the same thing, right? And what it is the texture size is the size of that text portion of the label. So we're just going to collapse that height. Texture size 0 would be the width. Texture size 1 is the height. And we're going to say make that height the height of the letters in the label inside those things. And let's see what we get there. So now you can see the title has collapsed to just the size of that, and the buttons also. But this is a little weird, right? I would have expected this to move down. What's happened is that although the buttons collapse down to their size, the button box, the box layout here containing the buttons did not, because we did not change the height on that. So it's still at the default 100 pixels height. So when you get some situations like this, you kind of have to look at the parent of those elements and say, oh, yeah, that's at the default size. How do I shrink that down to the correct size? And that is in step 5. And so here we'll fix that. We say, oh, I want the height of that box layout. I have no idea what it should be, right, in static pixels. I want it to be the height of the buttons it contains. So what we do is we give one of the buttons an ID. I call this the Say It button. And then we say, okay, I want the box layout to have the height of the Say It button. And so inside of the Kivy file, you can refer to other elements if you give them an ID. And they're actually working on something else where you can do it more like a tree, like you can say .child, or .parent, and you can go up and down that tree if you want, instead of giving everything IDs that you need to access. So let's see what we have now. So now you can see the button box has collapsed down to the size of the buttons, the minimum size of the buttons. The slider is still at 100 because there's no way to collapse that down to its minimum. All right. fonts. So the next thing was the buttons. The fonts are too small on those items, right? They look kind of weird. So let's do it again. And we'll go up and scroll down a little. So now we're going to adjust those fonts so they look better. The default font size, I think, is 12 pixels or so. So we're going to say, all right, on the buttons, I'd like to use a font size of 30 SP. And you can play around with that size. That's just one that works pretty well for the tutorial. But what I'm going to do is I'm actually going to make that a variable. So I put this at the top, at the root of my Kv file, button font size 30. And then at the bottom, the buttons, I can refer back up to that and say font size root, which is the root element of your GUI, button font size. So I can set that to be the same for all those. And then in the text input, I want that to the font size to adjust based on the slider, right? The slider value. So first I set up the slider. I say, all right, minimum value of 1, maximum of 100. Let's default it to 15. And we give it an ID, font slider, so we can refer to it from the other elements. So in the text input, then we hook up the font size to the font slider value. And we turn it into a string and do the SP, which is that resolution independent units. And let's see what we get. So now you can see our title is a lot bigger. It's the 30 SP, which is roughly 30 pixel font. Our buttons are bigger. They're at 30. Actually, I think the title's at 45. I didn't show it, but it's at 45. And now our font is at, or our text box is at 15, and we can adjust it just by moving the slider. So that's all the code we needed to bind those widgets together, the values of those widgets. We didn't do any other work. Let's see if I can, there's slider, and there's text input. So that's all we had to do to bind those widgets together. Didn't have to do any real Python. It's all in the Kv file. Now the Kv file is really very powerful. You can do almost any Python you want in there. I mean, here I'm turning things into a string, and I'm concatenating strings. You can actually import files. You can import modules and use them. You can do almost any Python that you want in the Kv file itself. It's very powerful. Once I realized that, it's like, oh, yeah, that makes it much more powerful than just a GUI layout tool. So for things like something that adjusts from landscape to portrait, and you want to move things around, you may be able to do that just in the Kv file without extra code. Okay, let's move on. What's next? Padding. Oh, yes. Okay. So although we adjusted our fonts, the size of the widgets were pressed right up against it. So we would like a little bit padding to make it look nicer. So what I'm going to do is do a padding variable basically in the root element. I'm going to say the padding for the root, I would like to be the width of it. So the width of the window, 2% of that. I want that to be padding in the width realm, or in the width, and then I got width here too, but it'll work. It's fine. I mean, it'll technically work. I think it's supposed to be height, and we'll try it with height, but let's see what we get with this. Did I do any other padding? Yeah, I did. There's a little more padding down here in the buttons to give them a little padding on the top and bottom. We still have the self.texture size, so the size of the font, and then we add that root padding value, 2% of the size of the window times 2. So, 4% of the root of the window size will make that padding. And this is kind of overly elaborate. You probably don't need to go to this route, but it makes for a nice effect if I change that one to height. So I'm going to do that real quick. So if I change this one that was root width to height, and then we'll run it. And so you can see we have padding now. We have padding based on the width and the height of the window. So here, this is 2% of the width. This here is 2% of the width. So it's just kind of a consistent value. Now if I change that window size, those paddings will change with it. So as I stretch that window, maybe hard to see, maybe if I go skinnier it's easier to see. You can see that padding gets skinnier and skinnier because it's based on that window size. So this is kind of cool effect, and you wouldn't normally use it, to drag the window size around. But when you're going to different device sizes with different screens, it can be nice to say, instead of 10 pixel border, give me 1% of what the screen provides as a border. What is that 15 minutes to? Oh, yeah. I don't know if we have to follow the designated break times, but thanks. I appreciate it. I don't think I showed the clear button isn't hooked up now, but that's all right. Okay, so let's go on. We've got padding now, and it adjusts with the size of our window. Step 8. Oh, the background image. All right. So the application has a background image, and you always want to put images in your application probably at some point. So the way you do that is you take the canvas. So in this case, we're going to put the image on the root element. You take the canvas of that element, which is where things are actually drawn. I think it's part of the OpenGL. And we say, take the rectangle portion of that canvas and stick this image in there. So that seems pretty simple. That's how you put a picture on any element, because they all have a canvas. Like a button has a canvas, you can put an image on the button. So let's run this and see what we get. What happened? Where's our picture? Well, you can see it even worse than I can on my computer. Way down here in the corner, it's about this big, right? It's a little gray box. You may not be able to see it on screen. But if you look at it, it's 100 by 100 pixels, right? The default size. So we have to actually figure out what size to make that image. Well, how do we know that? What's that? Yes. So let's fix that image size. So now we've still got the picture inserted the same way, rectangle. We got our source. But what we're going to do is set the position to the position of our element, which is the root element, and that defaults to the lower left corner. So we're saying position it there. It already was there in our case, but we'll do it anyways. And then the size, we could say width and height of the root, or we can just, since we're already in the root, we can say self.size and set width and height at the same time. So now when we run it, that image will be inserted, and then it will be expanded out to the size of the root element. Oh, need to run it. And there we go. Well, you can't see it. It's too subtle. That's what I get for using, subtleeffects.com or whatever. It's a pinstripe. You can barely see them. It's a dark gray pinstripe. Doesn't look that much different on the screen. But it's there. You'll have to trust me, I guess. Or if you're following along in the tutorial, you can see it now, right? Is anyone doing that? I'm just curious. Yeah? Good. Cool. Okay. So what's next? We're up to step 10. So let's actually do something with that button. Right now it's just we've got our GUI set up. It's all set up. So let's start doing some actions on our buttons. We still have, oh, I forgot to mention, what's going on? There we go. To do that image, I actually added an images folder into the project, and the image is inside there. The PNG is inside there. So that's at the same level as our main.py. I should have mentioned that in the last one. So now we're not going to, well, we are going to do something in the Kivy. So let's look at our Kivy file first, and let's have our button actually do something. We're going to start, I believe, with the clear button, which is simpler. So the only change we've made here is added this onPress event, root.clear. Now what does that mean? That's not a built-in function of the elements. That is, in our main.py, we have added a clear method to our formerly empty sayThis class. So we've actually added this thing here, sayWhatText is an object property, which we import above. That's part of Kivy. And what that does is that sets up sort of, it's another part of the magic, I guess you could say. When you call something there and you make it an object property, it goes into your Kivy file and looks for something with that name, which I have put at the top. sayWhatText, here we go. So we have our text input. Sorry, we'll go all the way back. On our text input, I gave it an ID of sayWhatText so I could refer to it. But to get at it outside of the Kivy file, I have to associate it here. So outside of the file, this is what I want it to be known as. Inside the file, this is what I'm connecting to. I could name those different things. They don't have to have the same name. So by putting it there, I can access it from the main.py. Let's look at that again. So here, our empty object property with the name sayWhatText goes out there, says, oh, hey, what have you got in the Kivy file by that name? Okay, that's what we're going to use. It hooks it up. So now in our clear method, all we're doing is taking the text field and we're setting it to nothing, empty string, and then we set the focus onto it. So that, presumably if you clear it, it's because you want to type something else in there. See how that runs. So here we go. So we've got hello world up there. If I hit clear, empties it and puts the focus back up in there so I can continue typing. Our say it button still does nothing because there's no onPress event for it. So to see again, clear. So I'll show those again. Let's start with the Kivy because it's a little confusing. And in our text input, because we want to refer to that from the class, we give it an ID. Text input, we give it an ID, and then because we want to do it from the main.py, we have to make this association in the root. And that's another thing they're working on where you won't have to make that association in the root. You'll be able to do it by child and parent. And then let's look again at the main.py. And we've got the object property, which we've set to the same name as from the Kivy file, and then our clear method that can now get at that. And what's more in here at the bottom on our actual button, so we do root.clear, which calls that clear method from the class. So you got to always sort of keep this in mind, how they magically merge, sort of magically. You do have to do a little work sometimes to get them to merge right. Okay, what step are we on now? 11. Okay, so let's actually work on our, we're not going to do anything, well, we do a little in the Kivy. Let's do that. So we're going to make the other button work, the actual button that makes it speak. So we already have our text with an ID. So all we're going to do is add an onPress event to that first button, the say it button. And we say root, say something. So we're going to add this method to our class in the main.py. What do we want it to say? Well, the stuff that's in the text box. And we could do that a couple ways. We can either put it in there, or we could just leave it out, and in the class we could refer to it out there. You could do that either way. I just chose this one. So in our main.py now, we've added the say something method with the text. It takes a text input, and in this case, it just uses subprocess to run the eSpeak program with that text. So assuming you have eSpeak installed, which I think it's in the virtual machine. I hope it is. Click the button.
Hello, Will.
Yeah, and there it goes. I don't know if you can hear it speak, but it did.
Hello, Will.
Oh, wait, maybe I leaned down. How about that?
Hello, Will.
There we go. So now our Say It button works. So let's look at the main.py again, which is the... Oops, didn't mean to run it. Just look at it. So all we did was we added the method, and then it just uses subprocess. So at this point, I want to talk about cross-platform, because here we're assuming that text-to-speak, we have eSpeak installed, right? And that is cross-platform, but very few people would have that installed by default. And when you go to Android or iOS, they aren't going to have eSpeak. So how do we deal with that sort of cross-platform thing, that kind of problem? And there really isn't anything in Python that does that. Things like text-to-speech or GPS or camera or notifications. Things like that on each platform is different. There's no module in Python to do that yet. So the Kivy team is actually working on a module to do that. They are very ambitious. And that module is called Plier. And so what I've done here is I've copied the Plier project and just inserted it into my code. So now it's a module. If we go into Plier, you can see it's a Python module. And we'll look at the facades. The way that they're doing this, see if there's a simpler one. It has accelerometer also. So right now, this is all that's available, is accelerometer, camera, notification, and text-to-speech. We'll look at text-to-speech, I guess, since that's what we're dealing with. And it creates a facade with a default action, right? And so when we say speak on our text-to-speech object, by default, it goes and does this private method, which does nothing. It just raises a not implemented error. So if you don't have eSpeak on your computer, it will just raise that error, and it'll bomb, really, unless you handle that error. So what they do is for each platform, we go into the platforms in Plier. We have Android, iOS, Linux, macOS, and MS Windows platforms. And so support for each of those platforms depends on somebody writing the code to support it. If you look in Android, we have accelerometer, camera, notification, and TTS. So all of this stuff has been written in there. If you look in iOS, there is nothing yet. And it just depends on the developers working on that. I have no iOS devices, so I can't really do it. So if you want to help out with this and you're an iOS developer, there's a lot of work to be done there in that project. So let's do... So we've got our Plier. So let's see how to handle that, the TTS in the Plier way, of cross-platform way. If we look at our main.py now, we've changed the say something from a simple subprocess call eSpeak. We now do the TTS speak. We try to do it. If we get not implemented, we throw up a pop-up, which we create actually in the code here. You could do this in Kivy, but I did want to show one way to create GUI elements programmatically. So we create a pop-up widget with a title, content, sorry, it's not available, and a size of 300 by 300. So I won't actually be able to do that because I have it installed. I guess I could uninstall it and show it, but that's all right. So this is sort of the future. there's just the 4 things that it works with right now, and on different platforms. I'm going to go into Plier more in the next section. This is, I believe, the end of part 1. Oops. Let me get back to my things. So we did that. Oh, come on. Yes. All right, so we made it, and we built it in the VM. Oh, I didn't show the Kivy inspector. I can do that real quick. It's very important, so I will do it real quick. We can just do it on this. If we run our... Oh, come on. There we go. So we run it again, and our say it still works here because we have eSpeak installed. The inspector, if you do -m, I always forget how to do that stinking inspector. -m inspector. Okay. Sorry. I do want to show this though. So the inspector is another Kivy project, and what that does is it helps you figure out where your widgets are. You hit Control E and you can inspect these widgets. All right, I want to see, what's a slider? What do I know about that slider? I can pull up the information, like where the center of that thing is, the height of it, right? Height 100, it's the default height still. You can get a lot of information about that, the opacity, the orientation, the padding on all of it. And you can inspect any of the elements in there. So this helps you very much with debugging your GUI if things are not where you think they should be. This will help you figure out why, or at least what the values are. And you can go to the parent and look at those, and then you just close it out. And all you have to do is you run your app with the -m inspector. That runs it with the inspector enabled. Control E turns it on and off inside of the app. Okay, that is the end of part 1. So let's take a break. And when we come back, we will be turning this app into an Android app. We'll be turning our Say This into an Android app using Python for Android. If you're not interested in the Android, feel free to not come back for the second part, to say it bluntly, I guess. We'll take, let's do, he wanted crazy hand signals to let you know.
Does it make sense that there's only half a room? Did you spare everyone off or something, or is this a new problem?
It makes, because this part is just Android, so iOS people or people who don't care about mobile would have gone somewhere else. Plus, there's good talks right now that people wanted to go to, and some people let me know they would be gone for the second half.
They got our permissions left.
Yes, they did. So yeah, this looks probably right.
Okay. Well, you still don't get the talk because she's pointed the wrong direction. That's one way of putting it right.
Okay.
I have enough things in my hand.
Maybe this?
Yeah, sure.
There's a tack up here too. It might be yours.
Ready?
Okay, here we go. Part 2. We talked a little bit about Plier for cross-platform. It becomes very important when you get to mobile because accessing things like text-to-speech, like the GPS, cameras, that sort of thing on a mobile device, they have APIs that are in the native language, right? There's Java APIs on Android, and there's Objective-C APIs on iOS, right? Something like that. So the platform independence becomes very important for those because it's very different than the desktops. What do I have? Oh, this was supposed to be in part 1. Oh, that's all right. This is how to information on packaging your application for deployment. So if you want to run it on Windows, the packaging guide will show you how to run it on Windows. OS 10 the same, iOS and Android is what we're going to cover now. Part 2. Hey, that's what I was looking for. So let's turn our application that we made into an Android app. And that's what we're going to do. The first thing you need to do is install Python for Android. In the virtual machines that's already installed, along with the other requirements, which are the Android SDK and the Android NDK, also Java and Ant, to do that kind of thing in Android. So there's quite a few requirements to get it done, which is why the virtual machines are nice. There are good instructions on the website too. But what we're going to do here, we're going to walk through installation a little bit, and then we're going to create the distribution, which is part of it. We'll add some of our Android resources, like an icon and a splash screen, that sort of thing that you may not get on the desktop applications, or that's really different. Then we'll make the APK, and we'll talk, if we have time, we'll talk more about PyGenius, which we'll see later. Or maybe we'll talk about it right now. So PyGenius is another Kivy project that takes the Android APIs. It actually takes Java, and you wrap your Java classes with a Python class, and then you can just call it from regular Python. This is sort of before Plier existed. This was how you would do the Python on Android, is through PyGenius. And it lets you get at anything you need to do on Android through Python. So we'll look at an example here. This is an accelerometer example from the website. And what we do is we import from Genius import auto class, and this is how you wrap the Java class. So we're going to take this org rempy Android hardware class, and we're going to wrap it. And so now in Python, we can just refer to that as hardware. So you can do like hardware.getDPI. You can do things like hardware.accelerometer enable. So you can get at this kind of hardware now through regular Python calls. Before Plier, this is how I did text-to-speech in the application we saw today. Import the auto class from Genius, and we take a Python activity, and we wrap. This is actually kind of weird. The RenPy is another project that does Python on Android. I believe it's a Pygame-based thing. So they sort of, Kivy takes that and uses it as a core in part of theirs. So what we need is the activity. If you know Android, you need like the Android, what is it called? I forget what it's called, some activity. M activity, and then there's another one. But you don't really need to know that much right now. But you get a Python activity, you take your audio manager, and we're going to auto class Android Media Audio Manager. So this is an Android API, right? Android class, and we're wrapping it with our Python so we can just use it as audio manager. So to do something like set the volume control, because there's media volume, there's ring volume, there's all these different volumes, you want your app, in this case, to just control the media volume, not the ring volume. So you have to set that. So we do all this work here just to set to stream music, which is what that volume control for media volume is. So if you were to look at the Java to do this, it's kind of similar. You'll need this class. You'd use this class here. You would use your Android activity, and then you set the control volume that way. I mean, it's kind of hard to explain. I guess in principle it's simple, right? You take your Java classes and you auto class it, you wrap it, and then you can use it in Python. But actually figuring out how to do this, what classes you need and how to call them can be difficult. You almost always have to go to the Android docs themselves. Yeah.
I was just going to ask, it surprised me that they didn't abstract that completely. And so you've got like a self-contained like Kivy audio class that you can like reference instead of having to refer to external docs.
Well, that's what Plier is going to do, is to take all the common things that people want to do and abstract them away. So you can do it in Android, you can do it in this other thing. Yeah.
Very cool stuff.
It's sort of, before anything existed, someone wanted to get at, the compass. How the heck do you do that from Python? So Tito again, one of the core developers of Kivy, said just created this in like a weekend or something. This whole Java wrapper in Python thing, and it works really well. So that was to set the media volume. Here's another example from before Plier. And actually, if you look at Plier's TTS, it's pretty much this still. It's just put into Plier so you can abstract it away. So we got the same thing, auto class. We need a locale, so we need to know what language we're dealing with. And that's an Android thing, so we have to get the Java util locale. We have to auto class that. We need our activity again. And then we need the actual text-to-speech, Android's text-to-speech capabilities. So we auto-class the Android speech, TTS, text-to-speech. And then we create an instance of that class, TTS, text-to-speech, Python activity, M-activity. So that's how you create an instance of the text-to-speech class. If you look at the Android docs, that's how they tell you to instantiate it. So it's sort of, it doesn't look as nice as if it was all Python. You still have to sort of look at the Java parts and figure out how it's put together. And here's where we set the language on that instance. We take our locale from up there and say US, and then we do TTS speak, which is part of the text-to-speech call with our message. And sometimes you'll run into Unicode stuff. You gotta a lot of times take your strings, your Python strings, make sure you encode them to UTF-8 when they go out to Java. Otherwise you get strange errors. Even without the weird characters, sometimes you get the strange errors. And then we flush it. That's how you call the TTS speak. So if you looked at the Android docs again, say how do I do a text-to-speech, it's .speak with all this stuff. So Python for Android is the Kivy project that lets you turn your Kivy app into an APK. So we're going to go over installing, creating what are called recipes, and then we're going to actually build an APK. So installing is not the simplest, mostly due to Android development is not the easiest to get going in the first place. You need both the native development kit and the software development kit, as well as the Python for Android project, and a few other things too. You make sure you read the install docs. And then once you've installed the NDK and SDK, you go into like your bash RC, your settings, and you set the paths to those. And when you run Python for Android, it reads those environment variables to figure out where the NDK is, where the SDK is, to figure out what NDK version and API version you're using. So these are important for Python for Android. And it's an easy to forget step too. So the first thing you do with Python for Android is you have to create a distribution. So what this is the core of your APK. Your APK will contain your code, and it will contain the compiled Kivy code and a Python interpreter. So it actually compiles Python using the NDK, compiles that all down, and it all gets included with your APK. This can make for big APKs. The minimum size I've found is about 6 megs. And it doesn't grow as fast from there because you've got the whole Python core already in there. What are you going to write that's bigger than that? But yeah. So what you do is when you create this distribution, you're creating that core. Now in this case, all I'm doing is including Kivy in there, which includes PyGenius also by default. But any other pure Python modules that you have in your code, those will work fine. You don't have to do anything special with those. But what you do have to worry about is modules with C extensions, because those have to be recompiled for Android. So they use what are called recipes for those kinds of modules. So things like LXML, NumPy, OpenSSL, PIL, all these things that have C extensions, they've created a recipe that will download that code, and then it will compile it for you, and it will include it. If there's a recipe that you need that doesn't exist, you have to write it, and it can be kind of fun. If we have time at the end, I'll show you a recipe. I worked on a recipe. I didn't actually write the whole thing, but I fixed it up for PD, which is a sound library. Pretty cool stuff. It can get complicated, but usually it isn't too bad. I mean, there's some problems with like setup.py, and you have to fidget with it a little, but I guess in all, you can take an existing recipe and adjust it for what you need, and it really wasn't that hard. So the next step, I should say, so Kivy, you could think of that as a recipe. Your other recipes you would put in front of that. So if you need OpenSSL, you say -m OpenSSL Kivy inside the quotes, and you just put them in that order. NumPy Kivy, whatever you need. OpenSSL NumPy Kivy. You just put as many as you need in there into your distribution. And then what we do is we need to build our APK. So we need to take that distribution and we need to combine it with our actual project and our images and all that other fun stuff and create our APK. So you go into your distribution that was created, dist, default is what it's always called, and you run this command, you run the build command. And now when you create an APK, there's a lot of options that you can use, right? You need like the package name, com.example.myapp, that sort of thing. You need the application name, so it could be PyOhio tutorial, the common name of your application, the version number, the orientation of your application. It used to be you had to specify portrait or landscape, and it was stuck, but they have now made sensor, so it knows when you turn your tablet, your code will adjust automatically. It's very cool. It's not something you really think about until it's not there. When your application is always landscape and you can't turn it. The icon for your app and the pre-splash screen, which is when it's like the loading screen, and the directory of your project. So you have to specify all these options on the command line. And you don't have to do all of them. Like you can leave out icon, pre-splash. I don't know what orientation defaults to, but you can leave it out. And you get like a default Kivy pre-splash and icon. And then when you create an APK, you have to specify debug or release. So we're just going to do debug here. Release has a few more options, like you need your signing key and all that fun stuff that a regular Android application needs when you create it. Yes. Where do I go? So we go back out here and we go to step 12 in our fun tutorial, or step 13 I should say. Ow. And so if we look at our project now, we've added quite a bit. We don't really need the make file. I guess we haven't actually added that much. We added this resources folder, right? What's in there? That's the various icons that we'll need for this. So I've got a regular icon. I've got like a high-res icon. I forget where that's used. But Android has like tons of icons if you want to create them. And the pre-splash image here. So that I've got all that stuff in the resources folder. If we look at this make file, so what I do is I have a make file that I take and I modify it for each of my Kivy projects. It makes it a lot easier. Is that a pun? Makes it easier. So here's the build command from my make file. And actually, is the distribute command on here too? Yes, the distribution one's on here too. Which is very simple. Distribute.sh, and then it takes the modules from up above, whatever I've specified. I think in this one it's just Kivy, so it's not that interesting. Yeah. But here's the build command I have. So we run the package and grab the package name from the settings at the top, the app name, the version, blah, 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 all on the same line there with the debug. and it just puts it all together, and then I make a copy of it out in the binaries folder. So we've got a compiled one. I can actually run it here. If we do make package Android, let's see if it goes. Building the distribution can take a long time, sometimes depending on how much stuff it has to download and compile. It does cache some of that. The build usually doesn't take too long. You see that's done already. But making the distribution can take a long time. That's where most of the compilation is. So now we've got our APK. You can take that and somehow get it onto your Android device, whether you plug in USB, copy it over, or a lot of times I'll put it in Dropbox and then just get at it on the device. But really, that's all there is to it. The other stuff, presentation. So we built it. We'll go into the extras a little bit here. Not that. I thought I had more PyGenius stuff, but I guess not. Are there any questions at this point? This is a good place for questions. Yeah.
Would you mind telling us kind of like an overview of what, I guess, the Kivy and also Flyer, what their roadmap is looking like? What are their priorities?
It's a good question. I don't know what the priorities are on Kivy right now. Yeah. Oh, repeat that. You wanted to know what the roadmap is for Kivy and for Flyer, like what their plans are.
So this kind of like compilation stuff, to me, it should be handled like in some kind of like config file, and I would expect Kivy or Flyers to kind of handle like the lower level like OS stuff behind the scenes.
Mm-hmm.
And I'm just wondering if they're kind of like heading in that direction, or if they're kind of like sticking with the per OS compilation kind of model.
Well, as a developer, I guess, or as someone who sort of works on the Kivy project too,
Okay, yeah.
I guess I'm more exposed to those underlying things. If you just want to use Flyer, you can just include it and use it. I wanted to show a little bit how it works, which is fine.
I'm not being critical of that.
Yeah.
It's just like as a developer, I guess that for myself, I try to encapsulate, and kind of like because everybody in this room will then have to learn like the kind of like application framework for each device that they're compiling on. And I love what you guys are doing. This is key. I'm going to be using your framework. I was just wondering if there's any thought.
Yes,
abstracting.
I do see where you're going, and they have a project for that. It's kind of funny. The Kivy team has tons of projects, and it's as I got into it, I've been using it maybe 9 months, not that long. But it's like, what would be cool is something like this that would do these builds for me, right? It exists. Okay. It's called Builddozer. Yes, and I don't think it does iOS yet, but it does do like Android, and I believe it does Windows and OS 10 stuff. So
this is like making me for the native application development. This blows everything else that I've ever worked with away.
Cool.
This is
good.
This is the direction I'm going. This is awesome. I appreciate you kind of pointing it out to us.
Blows it away, huh? Yeah, Builddozer is. It's sort of it was around for a while and then neglected, and now they're coming back to fix that. When I got into this, I was playing with make files a lot. So I have, a make file where I run make package, and it does all the work for me because it's already in there. But yeah, there are some ways of automating it. A couple other projects, I think it's one of the slides here, so I'll bring those up. Other cool Kivy stuff. Yeah, I'll show the Kivy catalog too. That is really cool. Builddozer, there it is. Create packages for all platforms. That's the goal with that one, and I'm sure all platforms aren't done yet, but they are working on it. Another cool one is the Kivy Designer, a GUI designer, so you don't have to do it all by hand, by code. There's a Google Summer of Code student working on it, I believe right now even. So he's working on that. There's Flyer, which is coming around, and then there's Kivy Garden as another new thing. And It's where people want to make, widgets that'll be useful to other people. A date picker, something like that, or even a number keyboard, that kind of thing, where you just want the numbers on the screen, where people can contribute those, and then others can go in and use them and modify them and improve them. So that's the garden. The remote Python shell on Android is very cool. What that lets you do, that's an app that you install on Android, and when you run it, you can then connect from your laptop over SSH into Android, and you can just run code over it, just like you're on a shell in there. And you can run, if you're messing with PyGenius stuff, it's really useful to try to figure out that. Instead of writing your code here, and then you move it over here, and then you run it, oh, that's broken, then you go over here and change it back and forth. You can just run it in a shell on Android. And it's got...
Is that like a REPL that will, I could import PyGenius and then make it speak via the
Yes.
remote Python shell?
Yeah, it's like a REPL where you can import PyGenius. I'm supposed to repeat the question. I don't know. Sorry. Yeah, it helps a lot with that sort of debugging. Kivy catalog is great also for learning widgets. I'm going to go back out here to the virtual machine. I actually installed quite a few different projects in there if you want to look at them. There's the Flat Jewels game I showed earlier, and pliers in there. Thought I had more, maybe not. But, in the examples. So if you go in the Kivy directory, in the examples, they have quite a few things in there. Demos, a little like a Pong tutorial. One of these, I believe it's in demo, is the Kivy catalog. So I'm going to run that. Oh. Looks like I need a module called Compat. Unable to locate Compat. I think it's PyCompat or something. Oh, come on. Yeah. I have no idea. What? I don't know if it's Python, is it? It seems like it would have been Python Compat if it was. Darn. Does anyone know what this... Oh, I ran out of room there. Nothing. Not found. There's nothing. I have no idea what that is. Can I run it? Let's see if I have it out here somewhere. Oh. So I'm going to go into... Oops. I really want to run this because it's very cool and useful. So I'm going to go into one of my other projects and then examples, demo, Kivy source, virtual center. Okay. Here we go. All right, so I'm running it on the desktop instead of the virtual machine until we can figure out what Compat is. So what this does, this is the Kivy catalog. It's in the examples. And it lets you play with the widgets live. So let's look at a layout. So we've got here a float layout. We can do things like play with this position of this button, right? So let's say, oh, I want this more at 400. Let's see what that does. Oops. And it reloads it a second later. So you can move things around on the screen. You can get a feel for how different widgets react in different layouts. You can resize them. You see here's some size hinting stuff. Right, we can change the size of that button. It's great for getting a feel for how different widgets work. On our box layout, what is this? We got our padding, we got spacing. What's the difference between padding and spacing? I don't know. Let's see, let's turn padding up to 100. What's that do? So that's the outside of the boxes, right? That's padding. Set it back to 10. Let's see, what's spacing then? Spacing is the space in between the buttons. So you can get a feel for how these different properties work. Play with the different layouts. Like I really don't know how anchor layout works. Oh, that's kind of cool. Anchor X, right? So if I do left, I can move everything over there. It's pretty cool. You can play with the grid layouts. Got buttons, and there's a bunch of examples in here to sort of get you started. But I think this one is really cool for exploring Kivy's widgets. See here, I didn't even cover the background colors of things. You don't have to put an image in something to change its color. You can just change, the font color, the background color on a button. We can change it to. This is RGBA, so red, 70% red, 70% green, 100% blue, 100% opacity, right? So that's how you specify the colors. So if I do, 0.1 or less red, turned more blue. I don't know how that shows up on this monitor, but more red. There we go, 100% red. There we go. You can see the colors change. But it's like a real live way to play with those instead of, change your code, run it, change your code, run it. I was trying to think of a way of doing the presentation in here, because I thought that would have been really cool to, build the application piece by piece, like with the code and it live updates. But I didn't quite get to that point. Wow, there's a lot of stuff in that one. Yeah, there's markup in there too. I haven't played with that at all. It's like Markdown. You can use Markdown, I think, in the text boxes, in the labels. That's pretty cool. There's a lot more to Kivy than what I covered today. I should let you know that. The Android stuff didn't take as long as I thought it would, but that's all right. Booleans? I don't know. Oh yeah, radio boxes, check boxes, progress bars. Maybe I should show this instead of the catalog next time. Or instead of the showcase. Oh, here we go. Look at that. So, no, the top one's a PNG. The bottom one here is an AVI. So it's playing a video down below, which is pretty cool. I didn't know you could actually embed a video. There's still, I have a lot more to learn too.
Gesture recognition.
There is not gesture recognition built in. There are some examples of it, so you can look at those and try to figure out, okay, tracing the finger this way, how do I turn that into a gesture? But there isn't a gesture recognition library built in. I heard about it once. Did that have gesture recognition in it?
There's a couple things. It actually has scheduling on the windows, so you can manage your windows. And
Oh, that's cool. Yeah.
hopefully they won't go there.
Yeah, they're working on it all the time. So, as people ask for things and they have time to work on them, they do, and they are very accepting of pull requests. So yeah, it's pretty easy to contribute. Even I have done it. You can also use RST in there, it looks like. REST document. All right. So let's go back to, let's see if there's any other cool stuff to talk about. Talked about the shell, bulldozer, designer, yep, plier, okay. Oh yeah, so as far as the community, I say it's a great community, it is. The IRC channel is excellent. There's almost always a core developer or 3 in there who will answer your questions. There's quite a few other people in there too. They had a programming contest early on, an app contest, and all of those apps are open sourced and they're on the web page. So if you want some examples of games, that sort of thing, to look at, that's a great place. They had a Raspberry Pi bounty, which they filled, and now it works on Raspberry Pi. They also have a grant from the PSF for some Python 3 stuff that they're working on. So, I mean, they're very involved in things. Google Summer of Code this year, and I believe last year they had someone too. More about Kivy, go to the website. There's also a wiki where people post snippets of useful things. There's a lot of that on there. And then there's also an additional list of projects that people have, like applications they've released and apps that are available in the Play Store, that sort of thing. There's a mailing list, there's a user Google group, and then there's a core development Google group also, as well as the IRC channel. My stuff, the tutorial is up on GitHub. I will put, somebody asked, I forget who, to put the virtual machine up someplace, and I'll do that. And I'll put it also in the repo. I'll link to it from the repo. All right. How much time do I have? What time is it?
Got about a couple minutes.
Just a couple? Okay. So I'll talk real quick. You guys feel free to leave if you want to. My motivation for working with Python and Android is I see that schools are handing out tablets to kids, right? And that becomes their only computer. And how do you learn to program on a tablet when that's all you have is a tablet, right? And you need all this other stuff to figure out how to program. You need a laptop, you need SDK and the NDK on Android, and you need an OS 10 computer with Xcode and all that stuff to do it on iOS. So I don't really like that situation. There are some projects now where you can do Android Java development on Android, completely on Android. You don't have to use anything else. But I don't really like Java. I want to see that in Python. And so about a year ago, I started looking at how do I do this? How do I get started doing this? And last year's talk at Pi Ohio was about all of the things that I had looked into to try to do that. It was pretty fun. And I hadn't actually used Kivy at that point. So it was soon after that talk that I actually used Kivy. And it's almost all the pieces are there. You can actually, if you install your APK on Android, once it's on there, you can move your source code. It puts compiled code in the APK. You can remove that and just put your .py files. Use an editor on Android, and you can just do it all on there. But creating the distribution and building that APK, those things have to be done on a computer, on a laptop right now. Once it's installed, you can mess with it. It's pretty fun to do that. It's also annoying if you're trying to do it on a phone. And so I have a tablet with a keyboard, and it's less annoying. But sort of my goal, where I want to take this, is to be able to do it all on there. Maybe off-source the distribution and then download it once it's compiled, that sort of thing. And that's what's motivated me to get into this. Well, thanks. I think that's the end, unless anyone has more questions. All right. Thank you.